My name is Oleksii Konashevych. I'm a fellow at Joint International Doctoral Degree Program in Law, Science and Technology funded by Erasmus Mundus. My supervisors are Marta Poblit and Pompeo Casanovas. This year I'm visiting RMIT University and collaborating with wonderful team of Blockchain Innovation Hub. And okay, a few words about my background. So I have a degree in laws. I worked as a lawyer for 10 years. I've got a degree also in economics. And the next year I will be finishing my degree, my joint degree in law, science and technology. As of today, I cannot say who I am more, lawyer or a software engineer. But anyway, this kind of interdisciplinary approach helped me to see a bigger picture and to design technical standards and algorithms to address lots of legal issues. And when we talk about the blockchain in public sector, there's probably the best word to describe what's happening now is hype, unfortunately. And the thing is that there are lots of misleading information, misconceptions in this field, and I will just go through a few of them. So, for example, Estonia doesn't use the blockchain, and you can find online their official statement. In Honduras, there is no land registry on the blockchain. In Sweden also there is no land registry on the blockchain. In Georgia, Bitfury introduced a small pilot project, but the results of these projects are questionable, and there is no ongoing project with Bitfury in Ukraine. In Ghana, there are no noticeable outcomes of this project, and in Cook County in the US they discontinued any further attempts to work on their system. Propi so far didn't show any results, and there is quite a long list of these kind of projects that pop up and unfortunately disappear. But the thing is that the use of the blockchain for public registries, there is no such thing as the use of the blockchain for public registry, because there are lots of ideas, lots of concepts, some of them good, some of them bad, some of them even ridiculous, some of them completely useless. But I've been working actually on the kind of higher idea, the idea of tokenization, where token is a kind of record on the ledger in the blockchain that represent property rights, and these property rights can be managed by smart contracts, automated by smart contracts, and using some other things like decentralized applications. And well, the problem of this is that the world of technology, especially blockchain technology, appeared incompatible with the law, with the world of laws actually. And I've been working actually to address these issues, developing this CrossBlockchain Protocol. So the CrossBlockchain Protocol is not only about the bundle of blockchains that we can use. The CrossBlockchain Protocol accommodates something that I decided to call smart laws. This is the framework for legal relationships. It also can accommodate not only public blockchains, but we can use in one bundle also permissioned systems like Hyperledger, or also centralized databases. There are some reasons why do we want to use these things. For example, there is a principle which is called technological neutrality. We would like to ensure actually that there is a free competition of technologies, and I, as a citizen, I would like to have a right to choose. Now we don't have, in many cases, don't have this right to choose, that the government just monopolistically decide, okay, say here is the electronic database, for example, land cadastral registry, and you can use only this kind of technology. So basically that's about it. And the blockchain in this story can be a registry. This is a kind of registry itself. Why do we want actually to use this? There can be multiple reasons in different countries. I'll just name them, like transparency, to provide more transparency, to reduce costs on public administration, to reduce bureaucracy by automation, to reduce corruption, to increase security of electronic systems, and in general to think about decentralization. But there are lots of issues with the use of public blockchains, especially when they're uncensored, when they're decentralized. Well, I will name them like immutability, hard forks, scalability, digital identity, privacy. I don't know if you're familiar with details of all of these issues. I can go through if you're interested. But I will name just that. For example, immutability, this is a kind of advantage of the blockchain. But at the same time, for legal purposes, for lawyers, for judicial system, it's a kind of headache, because how do we deal with all these things like dispute resolution, inheritance, and all these things? And many people actually think that probably better alternative is to use some kind of permission DLT system or private DLT systems. The thing is that I would like, for the moment, for those people who believe this is the only way how to address all these issues, to let's agree for today. Let's be open-minded and think about in other directions. Why? Because there are some issues with also permission DLT technologies, because they are centralized. There are different consensus protocols like proof of stake, proof of authority. In some cases they are centralized. In some cases they even not. They don't provide immutability. Here is just one possible scenario for rollback attack, but I cannot even call it attack, because that's a legitimate feature of this proof of stake protocol. So let's have we have this ledger, and the entity that has enough stake to decide, for example, 50 plus 1, and validate record. They can decide that they will rewrite the history. So they will choose the block and introduce a new fork, a new branch of this ledger, and all other nodes will drop the old version of this ledger. So that's the way how these things works. Of course, there are some other there are some things that can help to manage this kind of risk, but in general, for example, this kind of scenario will be in all cases centralized, and we cannot change anything in here, and we have to deal with all of these things. Let's talk about magic, the black box. I will begin with something which is probably those who don't know much about computer science and software engineering. This is two basic elements of any database. So there are at least key and value as an entry in the database. So key is a kind of, let's say, a serial number of the device. So basically that's something that represents the value. There is a technology which is called name value storage, NVS. It's been designed by a few blockchain projects since 2014. There are some other similar technologies, and probably most of current blockchain systems somehow uses these things. So basically it has dual nature. It provides entries, the technology for databases, and at the same time these records, these entries is something that we can own, and we can say it's a kind of token. This is something that you can own and transfer from one address to another. So a few words about this protocol. So on this side we have the ledger. On this side we have this database, public database. And this database is created, is designed, and actually entries are taken from the ledger when they are published on the ledger. So here is just example. I published my name, it's key, and value, my telephone number. And so now it goes here to this part, which is in here is the let's say immutable part of this system. This is a dynamic part of this system, and between these we have this protocol which provides us this interconnection. And so this element, which is called hook, will take records which are compliant with the standard which we all agreed to apply to our system. So that's why we have this kind of consistent database. And so when I would like to update my record, for example, I changed my telephone number, I moved to Australia. And so here I publish my key, Alex, my name, and my value, and the system will not create in here a new record, it just will update the record in here. So this kind of approach provides a few very important things that are valuable for the system. First of all, we can correct mistakes. So those people who say, okay, the blockchain does not allow us to correct mistakes, that's not true. It's a matter of a better design of the system. So in here, we just address this issue. So a unique key provides the consistency of this database, which means that while the owner of this record, nobody can take my token, nobody can take my property right on this record. And this is a unique record, and nobody can publish, again, Alex with something, another thing. Here is the CrossBlockchain Protocol that I would like you to explain right now. So in here is example of 3 ledgers that we use in the bundle. Here is the CrossBlockchain Protocol that provides rules and standards how we create our public registry. And here is actually our public registry, but it has kind of saying it's a public registry. It can be applied for multiple purposes like land registry, any property registry, whatever you want to design, or even database for telephone numbers. But at the same time, it is a standard database based on the technologies which are already in space for decades actually. And why do we need this database? Because that's a fundamental block for designing useful applications for end users, for end user services that we can use. So basically here is the very secure storage and the system that provides transactions based on smart contracts, based on some scripts and all these sort of things. And it works like here. So here the system will hook information which compliant with our initial standard that we need to apply. And so it will create this layer of the database in here based on something what happened in these blocks. So it also ensures that because I am the owner of this value, for example, of this record, nobody in here or here can take this record from me. So I am the owner of one record which is unique through the whole bunch of ledgers that we decided. And this protocol works in the way like, okay, let's agree together. Let's the government provide for us this protocol, and because all of us can install these wallets on our system and install this kind of protocol on our system, all of us will have on every machine exactly the same database, which is a kind of public registry for us, because we see the current state of all records we would like to manage in our system, in our community, for example. So here are 2 use cases for how do we manage digital identity on this system and how we manage property rights on this system. So here's Alice. She owns her private key. She created her public key and blockchain address, well, wallet as you wish. And from this wallet, she published her token that represents her digital identity. My name is Alice, and here's value, my telephone number, my email, whatever. Here we can also think another, it can be a name of the company. We can even here publish a cryptographic representation or cryptographic hash of the name, so nobody will know until she would like to disclose her information. How do we trust this token? Why do we know that she is Alice? Here's Bob. Bob knows Alice, and Bob published his token on his machine in the ledger using his wallet. And he says, I know Alice, and her digital identity is valid. Why do we need this thing? Because Now, while Alice controls his private key, she can update information. She can change her telephone number, her details, whatever have. But if she lost her private key, the blockchain is immutable, and the only way how you can access the system is her private key. If she lost, she will call Bob and ask him, please, Mark, update your record that says that my token is not valid anymore. In this way, we address the issues of immutability. But when Alice already has her digital identity verified and provided by someone whom we all trust, which is called actually trust service providers in Europe based on e-regulation. In other countries, it is called certificate authorities, but it doesn't matter, it's just a title of the technology. From this moment, Alice can create her tokens, create her smart contracts, and manage her assets. So let's have another scenario with her asset, with land title record. So here's again her private key, her address, which is verified by Bob. And here she created her token that represents her property right. Name is the key is cadastral number, some information about her land plot, and some other things. And here again, we need the government or someone whom we trust, because I don't know if this record truly represents her property rights. So here is Bob, and he's a registrar, he's a public office, and he says, okay, here is, I know this token, I know these property rights, and you can trust it, it's valid. The main thing in this story that all these kind of transactions can happen in different systems. So the cross-blockchain provides us that everybody will be using whatever technology, whatever ledger they want to use. So Alice chooses red ledger or red coin, Bob chooses green coin, and whatever, and they are interconnected through this protocol. And so now we came to a kind of bigger picture, and those people who believe that in the future we don't need any middleman, any third parties. Well, it's not true. Well, probably in some distant future, but now, I mean, there are lots of situations in our life and moments when people need third parties. A person cannot certify his birth. A person cannot certify his death. And so all of these things like validity of the identity, certification of some facts and events, notarizing contracts, creating assets and providing validity of these assets, all of these kind of things can be interconnected with these records on ledgers, and using cross-blockchain, they can work together. And so this thing is, how do we address the issue of hard forks on the system? So here's the problem. We have blockchain, and now we have two systems because they're split. And from this moment, I have two tokens in both systems that represents one property rights. That's a kind of legal collision. However, this is a kind of also called Schrödinger cat. Unless I move one of these tokens, there is no legal collision. But from the moment I decide which token I would like to use, the system will remember, here is our layer, our filter, that will remember that I have chosen this token, and whatever happens in this system with this token, the system will not allow to, will not show in, remember I showed this database. So this part is immutable, and this part is uncensored as any kind of public blockchain. So I can do whatever in here, and I can even transfer this token even if it's ignored by the system, but you will not see as a kind of public database. Exactly, or very similar to these kind of things, how we address the problem of immutability or enforceability of smart contracts. Let's say Bob has stolen the record of Alice of her land registry, of land title. So Alice went to the police, and the court decided, okay, that's the violation, that's the crime. And so the system provided a patch to the filter that will ignore the fact that these, well, let's say it's our social agreement, social contract. So because we trust the system, they provide new rules about, new knowledge about this token. And this knowledge says this token and this ownership is not valid for our system, for our community. We just ignore it. And so from this moment, Alice will be able to create her new token that represents her property rights. So we can think about this cross-blockchain protocol and smart law layer as a kind of filter. I call it jurisdiction as a filter. So let's imagine we have the country, and all transactions in this country, either they are provided by papers or electronic records, we don't care. Any transaction in this system can be either legal or illegal, either compliant or not compliant with our rules. So this filter is actually a set of rules that we apply on the system, and these transactions are either valid or not valid depending on how we decide with our community what is the justice and what are these rules that we apply. And so probably the final moment that I would like to discuss, this is a very important thing in this story, and probably it requires a completely different session to discuss all these sort of things. So because we cannot afford actually to publish personal data on the blockchain, because once it's there, we cannot change anything. So there are certain methods, rules, and algorithms that provides privacy on the blockchain. So I would like just to mention this framework, and actually this framework was adopted as official framework a few days ago. There was they've been doing this work, I guess, 2 years or something. So these kind of methods and protocols provides privacy, and it's called decentralized identifiers, DIDs. It's just an example. So one of these kind of protocols is called selective disclosure, provides that we can have all our personal data under our control, on our, for example, machine or my smartphone, and I don't need to disclose it. When someone, in some moments, I need to provide some personal data, I don't disclose everything. I just provide some, they're called leaves of the tree. So I decide, okay, you need my name, okay, here you go. Here's my name. But on the blockchain, we will see just cryptographic representation of this data, and nobody will be able to see what's happening there. Of course, we need hardware wallets to securely store our private key. That's another story. And there are certain protocols and systems that provide sustainable maintenance of these things. There are schemes for decentralized trust service providers. Remember, I showed you, Bob. So that's not necessary to have, like in Europe, the hierarchical root system where the government holds the right to say to provide the validity of the root. There can be also commercial entities, and we can also develop our web of trust. So because I trust Bob, Bob says, okay, I know Charles, so you can trust his digital identity. So I don't need to even to meet Charles in person to provide the transaction. And there is another scheme, like I can have one digital identity provided by different trust service providers in different countries. So it's more convenient to have this kind of things. And another scheme is like the last scheme actually that provides it's called derivatives. So I can have one digital identity, but I don't need, because it is based on the something which I don't want to lose, my hardware wallet. I can store it in a safe place, but before that I will create myself my own representation of my digital identity. For different cases, it can be even anonymous. So when I lost my smartphone, I don't need to go again to Bob or to the public office and to ask to reissue my digital identity. So that's why I can manage my digital identity, my own. So there are a bunch of questions that can arise from these protocols, like how do we perform atomic swaps on the system? How do we include new blockchains? How do we drop compromised blockchains? What do we do with tokens in dropped blockchains? How do we address issues with hard forks of cross-blockchain name index? The problem of astronomical network time and the synchronization, and how do we apply RAID protocols to secure records, and the governance of the blockchain. There's a bunch of questions. So these questions are addressed in this paper, which is now under review. Well, thank you for your attention. That's what I would like to present you.